Welcome to the lesson on drawing standards. This lesson discusses engineering drawings and explains why standards must be indicated on a drawing for the drawing to be clear. This is an important lesson because it shows you how engineering drawings and the use of standards impact your organization. Your goal for this lesson is to understand the importance of standards on engineering drawings. When you're finished with this lesson, you should be able to describe what an engineering drawing is, explain the importance of an engineering drawing, list 4 consequences of engineering drawing errors. List the 2 primary dimensioning and tolerancing standards used globally. Describe which ASME standards pertain to engineering drawings. Describe the role of dimensioning and tolerancing standards on engineering drawings. Identify which dimensioning and tolerancing standards apply to an engineering drawing. It will take approximately 15 minutes to complete this lesson. These are the new terms introduced in this lesson. It's important for you to know these terms in order to understand drawing standards. This lesson discusses engineering drawings, dimensioning and tolerancing, and the importance of standards. First, you'll learn about engineering drawings, the documents that most companies use to communicate product requirements. An engineering drawing is a document or digital data file that communicates a precise description of a part. If you take a look at an engineering drawing, you'll see that it consists of pictures, words, numbers, and symbols that are used to communicate the part requirements. Engineering drawing information typically includes geometry, shape, size, and form of the part, important functional relationships, tolerance or variation permitted for proper function, material, heat treat, and surface coatings, part documentation information, part number, revision level, etc.
Which of the following is included on an engineering drawing? You're correct. An engineering drawing's information includes important functional relationships. Click the right arrow to continue.
For more than 150 years, most engineering drawings were created using manual methods on mylar or vellum and were reproduced and distributed as blueprints. However, in the last 40 or so years, engineering drawings have been increasingly created on CAD systems. Take a look at this comparison of then and now for engineering drawings. An engineering drawing is an important document in an organization because it affects the success of both the product and the organization. The drawing establishes the goal for a number of departments, so if the drawing is vague, the entire organization is less efficient. The product function, manufacturing, and inspection all rely on the drawing information. Customer and workers' safety are impacted by the drawing information. Therefore, a drawing is a critical legal document in an organization.
An engineering drawing is a legal document. You're correct. An engineering drawing can affect the choice of measurement tools. You're correct. An engineering drawing has an impact on the choice of machines used to produce the part. You're correct. Click the right arrow to continue.
Engineering drawings need to communicate precisely, and they also need to be correct. Take a look at how costly a drawing error can be to an organization. In a medium-sized manufacturing firm, a drawing error found within the design department can be corrected for a few dollars. If it's missed there and discovered in the model shop, it may cost thousands of dollars to fix due to loss of material and machine time plus tooling and labor costs. When the error gets into production, costs escalate quickly. If you add up the cost to process the paperwork for fixing the error, plus machine, gauging, tooling, and scrap cost, it can total $1 million. If the drawing error gets into the final product, it's shipped to the customer and results in a product recall, it can easily cost the organization more than $1 million. If a liability lawsuit results, it can run into hundreds of millions of dollars. Take a look at the 4 ways drawing errors can affect the organization. Drawing errors can cost an organization money, time, material, customer dissatisfaction.
When is it most economical for drawing errors to be discovered and corrected? You're correct. A drawing error found within the design department can be corrected for a few dollars. Click the right arrow to continue.
There are 2 major dimensioning and tolerancing standards used around the world, ASME and ISO standards. The ASME standards are published by the American Society of Mechanical Engineers. Although they're created and predominant in the U.S., they're also used on engineering drawings in many other countries. The ISO standards are published by the International Organization of Standards. They're developed by international experts and used globally. This training is based on ASME Y14.5 2009.
The 2 major dimensioning and tolerancing standards used around the world are the SME and ISO standards. You're correct. Click the right arrow to continue.
If you're creating an engineering drawing, at a minimum, you should specify the ASME Y14.5 2009 standard. However, an engineering drawing will often indicate several additional standards. Take a look at this list of the ASME standards that cover engineering drawings and dimensioning and tolerancing. Do you know which standards are used on your company drawings? Dimensioning and tolerancing standards have a critical role in industry. Standards ensure common methods for specifying dimensions and tolerances, common interpretations of dimensions and tolerances. Take a look at this engineering drawing. The standards for interpretation are clearly identified in the notes, and it conforms with established national and international standards. Any specifications not understood by the drawing user can be interpreted through these standards. Without common specifications of dimensions and tolerances, engineering drawings would be more difficult to understand. Without common interpretation of dimensions and tolerances, it would be impossible to determine if parts meet their specifications. You may find this drawing more difficult to interpret. The standard for interpretation is not specified, and it does not conform with established national and international standards. Any specifications not understood by the drawing user may result in delays or errors on the part. Before interpreting an engineering drawing, you must understand which dimensioning and tolerancing standards apply to the drawing. You should look at the title block or in the notes area of the drawing, since these are the most common places to find this information.
Which standard applies to the dimensioning and tolerancing on this drawing? You're correct. The drawing title block says the drawing is per ASME Y14.5 2009. Click the right arrow to continue.
These topics are recommended for further study to improve your understanding of drawing standards. You have just completed the lesson on the importance of standards on engineering drawings. If you're not confident in your understanding of these topics, review the lesson information before proceeding. Close this window to exit the lesson.